Hello guys! In this video, we will be discussing about logarithmic equations. By definition, logarithmic equation is an equation containing a variable in a logarithmic expression. Now this is an example of a logarithmic equation. It's because it contains a variable in an expression and because of the log notation. Now, our goal here is to solve for x. We are going to find the solution and the value of x. Now, in solving for x, we need to follow some steps. The first step is that we are going to write a logarithmic equation on one side of the equation and the constants on the other side. Meaning to say, all the logarithmic expression will be transposed to the right, in my case, or to the left. You can transpose this log expression to the left and all the constants on the right portion. So we are going to transpose or transfer this log expression here, because this is first term, second term separated by addition operation. You can actually transpose this to the left. So this will become log with a base 4 of 5x plus 7 minus, from positive it will become negative, log with the base 4 x minus 3, and then all the constants must be occupying the right portion. All the logarithmic expression must be occupying or dominating the left portion. Now our base here is 4, and it's impossible that our base is an element of a negative number or 1, so we are going to avoid those things. And also, the value inside the parentheses of a log expression must be element of a positive number. Now, why are we doing like this? Why are we transposing all the log to the left and all the constants on the right? So that we can use the laws of logarithm. One of the laws of logarithm says that if we have log with a base a, m over n, then this is just equivalent to log m minus log n. Log n. So again, we have here log m minus log n, having the same base of a. And this is actually vice versa, meaning to say the right can be transformed into this expression, log of m over n with the base a. Now, if you will try to look at the given logarithmic equation, this is our m, and this is our n. And this one is having an operation which is subtraction operation that separates the two log expression. So we are going to transform this expression into the right one. So copying the log, copying the same base, which is in this case we have 4. And then what is your m? Your m is actually 5x plus 7. That will serve as your numerator over your n, which is your x minus 3. So m over n is actually your function inside the log expression. So you can enclose that. So basically, the left side is being transformed into log of 5x plus 7 over x minus 3 with a base of 4, following this property as part of the laws of exponent. And then we have to copy the equality symbol and the constant too. Now, this is our second step. Now, recall that the first step is that we are going to transpose all the log to the left in order to combine into a single expression. And this is now our step 2. What is our step 3? We are going to use the definition of logarithm to rewrite the expression in exponential form. Now, what is the definition of logarithm? If you could recall logarithmic definition, this is y is equal to log with the base b of x, where b is an element of a positive number not equal to 1, and x is also an element of a positive value. Now, this can be written as an exponential figure b to the y is equal to x. Meaning to say, the base raised to the power of y, which is equal to x. And this is actually vice versa because this is biconditional. So b to the y equals x can be written as y is equal to log with the base b of x, or y equals log with the base b of x can be written as b to the y equals x. And this is what we are going to do. Okay, our 2 is just corresponding to y. We have the log, we have the base of 4, and we have our x, which is equivalent to a rational figure 5x plus 7 over x minus 3. So we are going to transform this part here into an exponential figure b to the y. What is our base? That's 4. So that's 4 to the 2 if you're going to base on the definition. So we have here 4 squared, take the base, and the function 2 here, or the constant to the right. So we have 4 to the 2, which is equal to this function inside the log expression. So we have 5x plus 7 over x minus 3. What is our basis? The definition of logarithm. That is the third step. What is the fourth step? We are going to simplify the exponential expression and solve for the variable. So we are going to simplify 4 squared. This is now 16. And then copying, we have 5x plus 7 over x minus 3. And in solving for x, we are going to do the cross multiplication. So we are going to write on this part here. So continuation will be here. We know that 16 is understandable that this can be written as 16 over 1. And copying the right side, we have here 5x plus 7 over x minus 3. So 16 over 1 is still 16. So you can write like this so that we can cross multiply. So what is 16 times x minus 3? That would be 16 times x minus 3. And then 1 times 5x plus 7, that will become 5x plus 7. And then we're going to distribute 16 to every term of x minus 3. So 16 times x, that will become 16x. 16 times negative 3, that will become negative 48. And then we have to copy the right side, which is equal to 5x plus 7. At this point, we are going to simplify. So collecting similar terms, so we are going to transpose 5x to the left and negative 48 to the right to simplify. So 16x, copy, and then from positive 5x it will become negative 5x equals, copy 7, and then from negative 48 it will become positive 48. But what is 16 minus 5x? It will become 11x, which is equal to 7 plus 48, it will become 55. So in solving for your x, you are going to divide both sides by 11. So you are going to divide both sides by 11, and then you're going to cancel 11 over 11. What's left on the left? We have here x. Now what is 55 over 11? This is 5. Are we going to accept this one? Is this now our solution? We are not sure. It's because we are going to do the checking, which is now the 5th step. How to do the checking? You are going to substitute x equals 5 from your original problem, which is log with the base 4 of 5x plus 7 equals 2 plus log base 4 of x minus 3. In order to check your answer. Now, exclude from the solution any logarithm of a negative number. Such value is called extraneous solution. So if you will substitute x equals 5 to every x variable, then if ever the value inside is a negative value, then do not accept that answer because that is extraneous solution. For example, let's try to check. So in checking, all we have to do is to substitute from the original equation. So copy, we have here log with the base 4, and then we have here 5. Substitute x equals 5. So 5 times 5 plus 7, and then copy your 2 plus log with the base 4, and then substitute x with 5 because we're going to check minus 3, and then copy log with the base 4. 5 times 5, that's 25 plus 7, this is actually 32. Again, 5 times 5, 25 plus 7, 32, which is now equal to 2 plus log with the base 4. 5 minus 3, that's 2. Now, as what you have observed, our value inside the log or our logarithm is having a positive value or positive number inside. So meaning to say, x equals 5 is really our solution. Now, if ever the value inside is a negative value or the expression of the log is having a negative number, then you are going to reject your answer because that is extraneous. But it happens here that all of the number here are all positive inside the logarithm, then we are going to accept that. So we can actually continue. So what is log with the base 4 of 32 equals 2 plus log with the base 4 of 2. Then you can actually transpose log with the base 4 of 2 to the right or to the left if you want, but you can actually find the value of the left itself. Okay, how to do that? If we have here log with the base 4 is equal to 32, log of 32, you can use your calculator or you can use it, or you can solve for this value manually. So we are going to solve for the value of the left side, and this is actually question mark, or shall I say this is x. Now, by using the definition of the logarithm a while ago, so this is now 4 to the x So we have 4 to the x is equal to 32. Now, according to exponential equation, 32 can be written as 2 raised to the power of 2 times 2, that's 4 times 2, 8 times 2, 16 times 2, 32, so that's 2 raised to the power of 5. So this is now 2 raised to the power of 5. But 4 can be written as 2 squared, because 2 squared is just 4. But there is still a variable x, so you have to copy that also. So 2 squared is 4, but still we have an x, so copy here. And then since they are having the same base, so you are going to bring down exponents. So we have 2x is equal to 5. So you have to recall exponential equation. Exponential equation video was already uploaded. You can actually check it out. Now, in solving for x, you have to divide both sides by 2. Cancel that. So x is equal to 5 over 2. So therefore, our x is equal to 5 over 2, which is the equivalent value of this logarithm. You can actually check that using your calculator also. The value will be given right away. Is equal to, we have here 2 plus, what is the value of log with the base of 4 of 2? You can use your calcu, or you can have a manual computation. So we have here log of 2 with the base 4, which is equal to x. So by using the definition of logarithm, it will become 4 to the x is equal to 2. So this is 4 to the x is equal to 2. Now 4 can be written as 2 squared, because 2 squared is just 4. 4 is a perfect square. But still we have an x, so copy that, equals 2. Now this is understandable that it has an exponent of 1, because 2 to the 1 is still 2. Now are we having the same base? Yes, so we can now bring down our exponent. So we have 2x is equal to 1. So in solving for x, so x is equal to 1/2. So this term, log of 2 with the base 4, is having a value of 1/2, which is equal to log of 2 with the base 4. So this is now 1/2. Now, what is 2 plus 1/2? 2 plus 1/2 is just having an LCD of 2, so 2 divided by 1, because this is understandable that we have a denominator of 1, anyway 2 over 1 is still 2. So we have here 2 divided by 1, that's 2, times 2, that's 4. 2 divided by 2, that's 1, times 1, that's 1. So you have to copy the sign, the operation. So 2 divided by 2, that's 1 times 1, so we have here 1. But what is 4 plus 1 over 2? 4 plus 1 is still 5. Is 5 over 2 equal to 5 over 2? Yes, but the main goal of checking is that the number must be a positive number inside a logarithm in order to find and to conclude that x equals 5 is really our solution. But if ever we have here a negative value inside the log, either of the two log expression, then if you have a negative number, we call that extraneous solution. And do not accept your answer, but your answer, okay, is an empty set or a null set or no solution at all. So since we have a positive value, then therefore x equals 5 is our solution for this logarithmic equation. Thank you for watching.